Ooh, it's raining. Watch yourself, Jazri. It could drip upon you at any moment. Would anybody like to give me the right answer to the first one? Right answer. All I need is the answer, because if you didn't do it, then you shouldn't get to see how to do it, because that's, and if you did do it, you just mark it right or wrong. And if it's wrong, then you say, hey, how do you do that? So what's the right answer, Carlin? 5x plus 1 and x plus 2. Not 5x. And then, of course, Carlin checked. 5x times x is 5x squared. 1 times 2 is 2. If the ends are right, the middle's right. Good job. That's correct. Anybody need to see how it works? You shouldn't, because it's the very last thing we're doing, and you should already know how to do these. So if you don't have that, you're in a bit of a pickle right now. Who would like to give me the answer to number 2? Sorry, what was that back there? Correct. Who would like to give me the answer to 3? Six x minus 1. X plus 3. Oh, well done. Sounds like you just finished up there, Jazri. What's this one? Never mind. N plus 4 over 3. N minus 6 over 3, which gets you 3n plus 4 and n minus 2. This one is x minus 6 over 12 and x minus 2 over 12, which simplifies to 1/2 and 1/6 to get 2x minus 1 and 6x minus 1. This one, ooh, what's weird about 6 is backwards. Do the rules change? No. In all of these, you took the x squared term and multiplied it by the constant term, right? So what are we going to do here? Take the x squared term and multiply it by the constant term. So I need to multiply to what now? Look again. Right, I got to multiply to negative 30 and add to what? Negative 7. What is it? 3 and negative 10. So it's 3 minus or plus y squared. Ew. Plus, okay. Plus y, and that's over 2. And what's the other one? Minus 10 over 2 plus y. Does that work? Check. 3 plus 2y. And this would simplify to negative 5 plus y. Does that work? 3 times negative 5, is that negative 15? No. I need positive 15 there, don't I? So what's the 5 gotta be? If the 5's positive and the y is negative, let's check that. 3 times 5 is 15. Y times 2y is negative 2y squared. Then we have to check the middle here. Negative 3y plus 10y. Does that work? No, that gets me positive 7, correct? So it must have been negative 2y and positive y. Now, does that one work? 5 and 3 works. The ends work. 3y minus 10y. There we go. That's the correct one. Required you to check a lot. Is there something else you could have done here? So, okay. And then you could have done that. Maybe that makes your life easier. Up to you. Okay? 7 we already did. 8. A lot of people were asking questions about 8. So I would just like to take a moment here. And I asked everybody, why is 8 a problem? And everybody said, well, it's got an extra y in it. So let me ask you this. Could you do that with no y's? It would be super easy, right? Okay. And it would get you to this case. Got to multiply to 10 and add to negative 5. So it's what? What are the factors of... 4. Multiply to 4 and add to negative 5. So what are the factors? Negative 4 and negative 1, right? So it's x minus 4 over 2 and x minus 1 over 2. Simplify x minus 2 and 2x minus 1, right? Everyone agrees? Okay. X times x, 2x squared. They work. 2 times 1, positive 2. But I need that to be y squared. Well, you know that to get the x squared, I need x and x. So what do I need to get a y squared? Y and y. And I'm done. Would I ever write 1y? No. Would I ever take points away from you if you wrote 1y just to help yourself out remembering that it's 1y? Would I ever detract is the word I am looking for. Would I ever do that to you? No, of course not. Right? So I'm going to say it again. I will never give you something you don't know how to do. But I will give you stuff that doesn't necessarily look like you know how to do it. But you will always have the tools to get the job done. For example, if I gave you a sharp, pointy piece of metal, 2 pieces of wood, and a rock, what could you do with that sharp, pointy piece of metal, the rock, and the 2 pieces of wood to make those 2 pieces of wood stick together?
Make a fire.
To make them stick together. Oh. You would take the rock and the sharp, pointy piece of metal, and bang it in, and the wood would be stuck together, yes? Is the sharp, pointy piece of metal what you would normally look at as a nail? No. Is a rock a hammer?
For cavemen, yes.
But it doesn't look like what we call a hammer.
No.
But could you do the job?
Yeah.
Right, because you know that if you take something heavy and you bash something metal into wood, it'll go in and stick things together. Do that here. Try what you know before you say, I don't know how to do it. That's a crappy hammer. It looked more like a
rainbow.
A pickaxe for digging stuff out. A hammer would look more like this. That's better.
Yeah. No, I see.
Yeah. I'm pretty good at Pictionary.
Oh, yeah. We should have a class-wide game.
I've played Pictionary in class many times. Okay. All right, so 9 looks just like 8, yes? So I see I've got an n squared, so I know it's going to be n and n, but I also see an m squared, so I know it's going to be m and m.
Oh, gotcha.
I find it very funny that the biggest song in the world right now is a duet between Eminem, who was famous in like 2000, and Beyonce, who was the singer for Destiny's Child in the 90s. And yet, it's the biggest song in the world right now. And they're both, were famous 20 years ago. It's very weird. To me, at least. So, this is going to be negative 30. So it's going to be positive 3, negative 10. So n plus 3 over 2 and n minus 10 over 2. But what do I got to remember here? M's. Simplify, that doesn't simplify. 2n plus 3m and n minus 5m. Gotta have the m's. Now, question becomes, what if you forget the m? A factoring question like this, I would make it out of 2. Right? I would take away half your marks for forgetting the m, you think? I'm asking you guys, what do you think I would do? You've done the factoring correctly, so shouldn't you get a good mark? But what's the last thing I always tell you to do? Check. If there's no m there, can you possibly get that m there? So yeah, I'm giving you 1 out of 2, even though you've done your factoring right. Understand? You have to check your stuff over. There's no reason to not get it right. Okay? 6, 13. This is a little bit of a tricky one. 6 times 6 is 36, right? How do I get to negative 13 when I got 36? But they both got to be negative, don't they? That tricks people because they see that positive and they want positives, right? So it's x plus, see, I just wrote plus because I was saying positive, positive, positive. X minus 9 over 6 and x minus 9 over 4. Simplify where you can. That's 3 halves. 4 over 6, which is 2/3. 2x minus 3 and 3x minus 2. This one, again, tricky. How many of you automatically did 12 times 30? Probably a lot of you, and got 360, and you're like, yuck, barf, right? GCF it first. Make the numbers simpler, right? What goes into all of those? 6. 2s squared plus 11s plus 5. Now, I need factors of 10 that add to 11. Oh, 10 and 1, right? 6, s plus 10 over 2, s plus 1 over 2. Simplify 6, s plus 5, 2s plus, oh, I did my s backwards. I made a z. 2s plus 1. 9 and 10, 90 to get to negative 1. It's x plus 9 over 9, x minus 10 over 9, x plus 1, 9x minus 10. Now again, does that order matter? No. Do those positive and negative signs matter? Yes. I can't mix up the positive and negatives, but I can switch the whole binomial. Because 5 times 2 is the same as 2 times 5. Everybody's cool with that? That's why you always check at the end. What's weird about 13? All of them have variables. We only know what to do if this last one is a squared, yeah? And it's not, so we got to get rid of an x. So x comes out, leaving us 4x squared minus 7x minus 2. Oh, that I know how to deal with, right? Now, if you stop there, what am I giving you?
1 and 2.
You've done half the work? All you did was GCF.
Oh, okay.
What do you think I give you? There you go. Picking up what I'm putting down? Finish that trinomial. And it's got to be 8 and 7, right? Negative 8, 7. So it's got to be x plus 1 over 4 and x minus 7 over 4. Right? No. 8. Sorry, x minus 8 over 4. And then it's x, 4x plus 1, x minus 2. This one looks just like number 8 and 9, was it?
Yeah.
Right? 40 and 22, d plus 20 over 8, d plus 2 over 8. What do I got to remember? Got to remember the e. That simplifies to 5 over 2. That simplifies to 1 over 4. 2d plus 5e. And 4d plus One E would be allowed. E is better. And finally, perfect square, yeah? So 2a plus what? Or do you have to do the long way? Sometimes you can use the perfect squares, yes? Can you use the perfect squares here, or do you have to do the long way? Somebody did 15. What did you do? You did the long way? Okay. So you got to multiply to negative 36 and add to negative 9. What is it? Right. A plus 3 over 4 and a minus 12 over 4. 4a plus 3b, right? And 3, yeah? A minus 3. Works. Yeah, a minus 3b, of course. Now, why did I talk about those two squareds? Because sometimes those two squareds give you a hint, don't they? If all this was positive, then I could use those squareds to help me, couldn't I? Right? Then it would be 2a plus 3b squared. Move on to the extra 6 I gave you. I hope everybody at least tried them. There was one thing about all of them that was tricky. What was tricky about the first one? They were both negative. Right? That messes you guys up. So I need to multiply to negative 84, but add to a negative number. Right? How do I keep this negative, but still get a negative? One's positive, one's negative. Which is the negative one? The bigger number or the smaller number? The bigger number. So this had to be 12 and 7. And it had to be x plus 7 and x minus 12. Right? That's the trick there. To keep that negative and that negative, got to keep the bigger number there. Now, number 2, I didn't see you guys yesterday because I spent a lot of time with a couple of people, so I didn't get around the class as much as I would have liked to. But my afternoon class spent forever on this question. Why? It can't be factored. And they still spent hours trying to make it work. Okay? If you have to unscrew something from the wall, and the screw that's in the wall has the flat head screw in it, and you have a Phillips head screwdriver, will you, the X, the plus sign, will you ever get that screw out of the wall? No, because you can't. So when you come up to something that you can't factor, you don't try to make it factorable. It just isn't factorable. Do you understand? Don't try to put a square peg into a round hole. Picking up what I'm putting down? Read my mail, mowing my lawn? It's a quick check. 3 times 20 is negative 60. Got to add to negative 3. 1 and 60, that's not getting to 3. 2 and 15, that's not getting to 3. 3 and 20, that's not getting to 3. 4 and 15 is not getting to 3. 5 and 12 is not getting to 3. Nothing's getting to 3. So I can't factor it. Oh, wait a minute. Maybe I could GCF it. 3, 3, 20. No, I can't even do that. So it's already done. That's why I did it to you. And I know it was a mean move, and I shouldn't have done it. Blah, 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 blah. But the reason I did it is because on your test tomorrow, a great many of you are going to try and do things that you cannot do, even though we've had this lecture. Please don't. Know when you're done. Okay? What's weird about 3? What's weird about 3? I hope everybody's saying nothing's weird about it because you all immediately see how to do it. What are you going to do there? I've given you a couple of options. Somebody did 3. What'd you do? Pardon? Nobody did 3? Hurtful, guys. I made these up out of my head to help you. Okay, so then you have 4a squared minus 25. Now, is that a perfect square? Is that a perfect square? So is that subtraction? So can I do the move? What's the move? Square root of the first one, which is what? 2a. Sorry, thank you. 2a. Square root of the second one? 5. And then I write it again with the negative. But there is no a, is there? It's x minus 4, right? So it's really 2x minus 4 plus 5. 2x minus 4 minus 5. Now what do I got to do? What do I got to do here? Distribute. Practice for polynomial multiplication, which I am making you do on this test, yes? What is that? (2x minus 8 plus 5). What's that? Minus 5. So what's my final answer? (2x minus 3 and minus 13). Then I'm done. Okay? Okay. Just out of curiosity, is there anybody in the room that doesn't get this move? Is there anybody that doesn't see how that works or why that works? Because if you don't, there's other things you can do here. It's just a lot more work. So I didn't give you those methods. I gave you this super easy way to do it. But is there anybody that doesn't understand this move? Please tell me, or if you don't want to tell me now in front of all your peers, come and see me at lunchtime if you don't get this move, okay? Because there is another thing you can do, but it's a lot more work. But it might be helpful if you don't understand this, okay? So I'll leave that with you to make up your mind if you're one of the people that needs to come and see me about it or not, okay? What do I do with 4? How's 4 different than 3? Because they look really, really similar, don't they? Pardon me? They're not perfect squares. So what do I do if it looks like something that I can almost work with, but I can't quite work with it? What's the move I'm supposed to try? GCF. Is there a GCF there? What is it? 6. So if I take the 6 out, I'm left with x minus 3 squared, right? Minus what? 4. Is that a perfect square? I still don't like it. So what would I probably write there? I would probably make that a substitution situation, right? Then it's 6a plus 2, a minus 2, yeah? Because am I allowed to forget about that 6? No. How many of you are going to forget about that 6 on your test tomorrow? No, none of you, because I'm reminding you right now, again. I've said it a few times. What is a really? It's x minus 3, yes? So what's x minus 3 plus 2? Minus 1. And what's x minus 3 minus 2? Minus 5. And then I'm done. Everybody cool? Okay. And finally, the ones that usually cause the most grief. What's this one? What do I got to multiply to? First of all, can I GCF it? Always check, can I? No. So what do I got to multiply to? Negative 42. What do I got to add to? Negative 19. Now this one gets weird because it goes past the 12 times table, yes? Because I got to go all the way up to 21 and 2, don't I? Which one's positive? 2. So it's going to be x plus 2 over what? 7. And x minus 21 over what? 7. Simplify. Does that simplify? 7x plus 2. Does that simplify? 3x minus 3. Cool in the gang? Okay. And 6 is about the hardest question I can give you in factoring in the 10th grade. Because there's a number out in front, right? And it's GCFable. And it's a binomial there instead of a single letter. Holy crap, it's got everything, doesn't it? So where should we start? Okay, what's the GCF? 2. So 2 comes out. Then inside I've got 2 x plus 7 squared minus 7 x plus 7 plus 6. Right? Now what should I do with those x plus 7s to make my life easier? And now it's super easy, right? Can I forget about that too? No. So that is going to be, what's 2 times 6? Multiply to positive 12, add to negative 7. What is it? Negative 3 and 4. So it's a minus 3 over 2 and a minus 4 over 2. What do I do with those fractions? Simplify if you can. Does that guy simplify? Can't simplify him. So it's 2a, but it's not a. What is it? X plus 7 minus 3. And a, but it's not a. Wait, simplify. Does that simplify? To what? 2. It's not a, though. What is it? X plus 7 plus 2? Minus 2. Now I simplify. 2. 2x plus 7 is what? 2x plus 14 minus 3 is 2x plus 11. And x plus 7 minus 2? X plus 5. And that's about the hardest thing I can give you. The only way I could make this any more difficult was if one of these or both of these could factor. You understand what I mean by that? Don't write down what I'm about to do, but just this is the only thing I could do to make it more difficult. Let's pretend you do all the work and you get to here. Can you do anything more with that? I can do something right there, can't I? What could come out of there? 2. So I would bring that 2 out. I've already got a 3 out there, so it's 6. X plus 7, x minus 3. That's about the hardest thing I could do to you. If you can understand this after you've done everything in number 6, even if you can't quite do it yourself, but you get it, you're in very good shape. Is everybody in good shape? Yep. If you're not in good shape, then you're actually in very good shape because, again, as mentioned during the announcements, I forgot my lunch. So I will not be leaving here at all at lunch today. That's a bit of a stretch, Rihanna.
But it's still good. It works, does it not?
No.
Yes, it does. We work with shapes and math, do you know?
Rihanna, I feel your pain of when you tell what you think is a funny joke and all you hear is crickets.
Yeah.
Because I tell a lot of funny jokes. And all of you sit out there. Some of you sit out there like this. No names mentioned. Some of you sit out there like this. Some of you sit out there like this, wishing you could have your middle ones up. And it's hurtful, I know it. It's tough. You go out on a limb, right? To try and say something funny and brighten everyone's day, and what do you get for it? Crap! I feel your pain, Rihanna. And shame on all of the rest of you. Shame. I think some people need to come and talk to us. You guys can come in. I know what you're doing. I've been awaiting you.
The other ones are so good. I'm gonna just hand this around and then you all answer the questions in the survey for a math project.
They're doing projects in math. You can't do a project without data.
Can we do a project?
When we get to something that is projectable, we can. Hard to do a project on factoring trinomials. Right? So guys, listen please. Listen please. There's a reason I've spent the last 5 minutes jibber-jabbing about nothing. I was kind of hoping these guys would get up here because I was expecting them today. You're going to fill out these sheets. It's going to take like 2 seconds and they're going to be able to do their math project. Okay? It's a nice break. Where's the sheet? First guy's sheet is where? Just fill it out, Co. Put information on it. So here is all you do. You put a tick by whatever one of these applies to you. Okay? We'll start over here. Read the thing, put it, just a tick is enough, guys? You're just trying to do a tally chart, yeah? Okay? It won't take long. And we're helping other math people. You can even do it 2 at a time, like those guys are doing. What do you got? You got a different survey? You're killing me, man. That's okay. And this is recording. If you don't write it down right now, if you want to check on it later, that's cool too.
Yeah. Congrats. I'm writing them now.
Are we ready to look at the first one? Now listen, please. If you do not care to go over this right now, then do your classmates that do care the courtesy of shutting your pie hole. Okay? Because some of your classmates did want to go over this. They specifically asked for it. So, what are you going to do with this first one? You're going to write it out. How many times? Thrice, because it's been cubed. Now, I like to pick 2 of them. I always pick these 2 and leave the first binomial alone. That's just because for me, that's how I like to work on it. You don't have to do it that way. It doesn't matter. So then I get 4x squared plus 6x plus 6x plus 9. 2x plus 3. 4x squared plus 12x plus 9. Now I do this again. The 2x goes everywhere. 8x cubed plus 24x squared plus 18x. Now I'm done with the 2x. So I'm going to cross them out because I'm finished with them. Then I'm going to use a new color because I'm starting a new line. 12x squareds. I keep my x squareds together plus 36x, I keep my x's together, plus 27. Then I add it up. 8x cubed plus 36x squared plus 54x plus 27. Please notice that all I have been doing is what you learned in the 9th grade when we showed you this. That was 3x plus 3 because you distributed in. All we're doing is that. You took the first one and you distributed it in 3 times. Then you took the second one, you did it 3 times. How many distributions do I have to do here? How many distributions do I have to do with the y squared? 3. How many do I have to do with the 3y? 3. How many do I have to do with the 7? So I've got to do 9 distributions, yes? So the y is going to go first. Y squared minus y cubed minus 4y squared plus 8y. Easy peasy, right? Pretend like those two aren't even there. Now, we're going to pretend like only that guy's there. He's negative, so it's... Sorry, that first one is y to the 4th, then y cubed, then y squared. Now this guy is negative, right? So when he hits this positive, what wins? So it's negative 3y cubed, and I keep the cubes together. When this negative hits this negative, what happens? Positive 12y squared, and when this negative hits this positive, what happens? Negative 24y. Then I'm going to go to this guy. That 7's positive, yes? I got to do 3 more distributions. 7 and y squared is positive 7y squared. And I keep all my squareds together. 7 times negative 4 is negative 28. And 7 times 8 is 56. Then I add it up. Now here is where a ton of you make mistakes. You feel you can add in your head. Even though I ask you every day, what's negative 7 minus 9? And half of you get that question wrong. What is it, Jashin? No. What is negative 7 minus 9? Negative 16. What is negative 7 minus negative 9? Positive 2. If you don't have those answers immediately in your head, should you be attempting to add this up in your head? No. What should you be using? Calculator. Y to the 4th, nothing adds. Negative 3 and negative 4 is how many negatives? Negative 7y cubed. 8, 12, and 7 is 28y squared. Negative 24 and negative 28 is what? 27. Thank you. 27 y squared. And what's this? Negative 24 and negative 28. If you can't do it in your head, just think to yourself, I got a bunch of negatives, then I got a bunch more negatives, so it has to be more negative, which is negative 52y plus 56. If you can do those two, you can do all the multiplying that's on tomorrow's test. Because those two are way harder than everything I put on there. Except I think there might be one of these on there. Now, let me ask you this. Could you handle this? What do you do first? What do you do first? Have you been given a roadmap in math to what you do first? Starts with a B, ends with an S, has EDMA in the middle of it. Right? You're going to do BEDMAS, which says we start with brackets. There's crap tons of brackets there. But those aren't the brackets I mean, are they? Then it says exponents. Any exponents there? No. Then it says division. No division there. Then it says multiplication. So where's the multiply? Right there. So that's where I start. Can I use my shortcut there if I know the shortcut? Yeah, because it's just x and x. If I don't know the shortcut, I got to double distribute, don't I? I'm going to use the shortcut. X squared minus 3x minus 10, yes? Then minus x plus 7, right? Okay. Any other x squareds? Nope. But it says I got to take away an x. I've already got negative 3. What does that become? Negative 4x. And then it says minus 7. I've already got negative 10. Am I getting more negative or less negative? More negative, so it must be minus 17, yes? What if I change this 7 to a negative? Then it's minus 7, which is what? Plus 7. Negative 10 plus 7 is negative 3. If you can handle that, you're in very good shape for half of your test tomorrow. The mistake a bunch of you are going to make is you're going to multiply here, even though that says subtraction. What if I gave you this? What would you do in blue there? You'd multiply that, and then you would subtract. What would that minus sign do to x squared minus 5x minus 14? What would that minus sign do to all of those? Change it to positive, positive, positive. Everybody cool? Great. It's almost like you're ready for a test tomorrow. Now, Carlin specifically asked for a couple of the substitution ones, right? If you can do this, x plus 3, that was stupid. Don't. X squared plus 4x plus 5. If you know, no, that won't work, sorry, plus 3. X plus 3, x plus 1, yes? If you can do that, then you can do anything that looks like that. This says that the first term is squared, yes? And then that same number lives there, right? That's what the x's mean, correct? So whatever I write there, as long as it's squared, it would go in this spot, yes? And as long as this is the same, I can do it. So if I gave you this, could you factor that? You absolutely could, because isn't this just x squared and 4x and 3? Isn't it? So we know it's 3 and 1, right? And we know it's x and x. But in this case, x is this giant thing, isn't it? So what would it be? It would be y squared minus 7y plus 12 plus 3. Yes? And then what would the other one be? Y squared minus 7y plus 12 plus 1. Yeah? Everyone agrees?
Oh, yeah.
Okay. Now what would you do with this 12 and the 3? No. plus 15, right? And this one would be y squared minus 7y plus 14, yes? 12 plus 1. 13, yeah. Now, looking at those, you would look again and see if those are factorable. They're not, but you would check for it.
There's like 4 minutes left.
Test tomorrow. I know, it's weird.